All right, so on this journal here, journal 24, we're going to start out with a bell work where we're foiling out two of these factors, but they have imaginary numbers in it. So just as a quick reminder, I, or imaginary numbers, I is the square root of -1. But we also learned that if you square I, you get -1, which is not an imaginary number, it's a real number. So when you square an imaginary number twice, you get -1. So on here, if I were to FOIL this out, you gotta take your first term, multiply with your first term, so that's 9. 3 times 3 gives 9. 3 times I gives me positive 3i, and then if I take the negative I and multiply it by 3, I get -3i. And negative I times negative I gives you -I squared. So we're going to try to combine like terms here, but notice in the middle here, these are opposite signs but same coefficients. So when you combine them, they cancel, right? So that's great, the i's cancel. And then we have an I squared here, so we got to change that to a -1 because I squared is -1. So first I'm going to bring the 9 down. And then I have a minus I squared, but I squared is -1. So two negatives make a positive. So this is really 9 plus 1, which is 10. So my answer here is really just 10. Wait a minute. So I just went from taking a complex number and a real number and imaginary numbers, and I just got a real number in the end. So basically, when I multiplied these two factors, I end up getting two imaginary numbers. And let's understand why. Notice how these are the same factors, like literally the same terms. That's a 3, that's a 3, that's an I, that's an I. The only difference here is the signs are different. So let's see what happens when I multiply something that is the same factor but just different in signs. So here I go again. 4 times 4 gives me 16. 4 times 5i gives me 20i. -5i times 4 gives me -20i. And -5i times 5i gives me -25i squared, because -5 times +5 is -25. I times I gives you I squared. So now notice again the middle terms are opposite signs and same coefficients, so they are going to cancel. And then again, I have an I squared here, so I have to change that. So I have 16 minus 25, -1. So these two will combine to make a positive 25. So 16 plus 25 is, let me think about that. So 16 plus 25 gives me 41. Yeah, 41. So in this case, I'm back to a real number again. So it's almost like, so if you're asking yourself, what are you noticing about these products, meaning when you multiply these two factors, right? It seems like after, let me grab my pen here, after the factors are FOILed, or multiplied, the middle terms cancel. So it looks like the middle terms always seem to cancel out when they're opposite in signs, right? So because they are opposite in signs but the same factors, they cancel out the middle terms. And this is actually a technique we use a lot in mathematics. So let's give that a name. All right, so what you guys just observed a moment ago, when you multiply a factor that is the same but opposite in sign, that is called a conjugate. A conjugate is where we change, let me grab my green pen here, where we change the sign in the middle. And so in this case, like, let me give you something very generic, like a template of some sort. So let's say we have a real number, added with b, an imaginary number. Well, the conjugate of a plus bi would just be the same factor. So it'd still be A, B, I, but it'd be a minus sign between them. And you can even say that A minus BI is the conjugate of the other, right? You can go back and forth with this. So if I wanted to pull a conjugate out, I just flip the signs. But I make sure that the terms are still the same, like they're that's still, A and that's still B. So an example of this, let me just make one up. So let's say I have 6 minus 8i. Well, the conjugate would be, 6 plus 8i. All I did was change the signs. So these two are conjugates of each other. And conjugates are really useful. So especially when we're dealing with dividing imaginary numbers. So the other journal or the notes before, I taught you how to deal with imaginary numbers when you are adding imaginary numbers, when you're subtracting imaginary numbers, so combining like terms, and then when you're multiplying imaginary numbers. But I didn't show you how do we divide by imaginary numbers, and that is what I'm going to show you how to do today. Now, let me just say here is it looks like a fraction, right? Fractions just mean dividing because you're taking the top and you're dividing the bottom. Now, here we're just trying to simplify this, but you would think that dividing imaginary numbers is how we've always thought about dividing. You would take the top and divide at the bottom. The only thing is imaginary numbers don't work that way. The reason why is because, well, you can't divide with an imaginary number. So in other words, I can't be in the denominator. So we need to get rid of I in the denominator. And so, well, how do I do that? Okay, so we're going to pause here for a moment. I'm going to stop working on this problem and just bring up an idea of fractions, okay? Let me bring up this idea. So you remember in elementary school when your teacher asked you to add these two fractions together? Let's say 1/2 with 1/6, right? Well, first off, you can't add these because the denominator aren't the same. So in this case, you have to change the denominators to both be the same. So 2 and 6 can both be 6 if I multiply the 2 by, well, 3. So if I multiply the top and bottom by 3, actually, let me just rephrase this for a moment. So in order for this bottom to be a 6, I have to multiply the bottom by 3. Anything you multiply to the bottom, you must multiply to the top. So this top here will also be a 3. The reason why we do this is because 3 over 1, or any number over itself, is just 1, right? So you're really technically multiplying this fraction by 1, so you're really doing nothing to the fraction. And that's exactly what we want. We want to change the way it looks, but not change the fraction completely, okay? So in this case, we're basically tripling this fraction. So if I were to do that, let me bring this over. This would be 3 over 6, right? If I multiply straight across. And then I add the 1/6. The denominators are the same, so I just add the top, bring in the bottom. The bottom would be the same, right? Because you don't want to add the denominator. So the denominator is still 6, and then you might try to reduce it. And so reducing would be 2 over 3 because 2 goes into 4 2 times, 2 goes into 6 3 times. All right, so that's like your idea of, normal adding fractions. So I bring this up because these are skills that we still need for imaginary numbers. So first off, going back to this problem again. So I said a moment ago that you can't have i's in the denominator. So to get rid of this imaginary number, we've got to think about some skills that we might have learned to help us get rid of imaginary numbers. Well, you might have noticed in the bell work, right? When we were foiling out those conjugates, we noticed that the middle terms cancel. Well, when the middle terms cancel, the i's canceled. So all of the imaginary numbers cancel, giving us just a real number in the end. So if I want to get rid of this denominator if I want to get rid of the I in this denominator, I need to multiply the bottom by its conjugate. So the conjugate of 3 plus 5i would be 3 minus 5i. So I'm going to multiply the bottom by this conjugate. But anything I multiply to the bottom, I must multiply to the top. And so now what I'm going to do is, well, I have to multiply the fraction straight across. So what I like to do is put some parentheses around my my numbers so that I can easily distribute. So when you're multiplying across, let me bring in a new fraction here. So I'm just going to focus here on the top. If I multiply these two, I'm basically distributing this negative 2i over, so that'd be negative 6i, and then negative 2i times negative 5i, well, that'd be positive 10i squared. And now I'm done with the top. And so then I would move on to the bottom. So 3 times 3 gives me 9. 3 times 5i gives me negative 15i. And then 5i times 3i is positive 15i. And then 5i times negative 5i is negative 25i squared. All right, so let's try to clean this up a little bit. So the top here, I notice that there's an I squared, so I can change that to negative 1, because I squareds are just negative 1. So that's negative 6i plus 10 times negative 1. The bottom, notice that the bottom here, these two are opposite signs, but the same coefficient, so they're going to cancel, which is great, because then the i's disappear. And then the 9 comes down, the negative 25 comes down, but then I notice another I squared, so I'm going to change that to a negative 1. And so now I really have negative 6i in the top times 10 times negative 1, which is negative 10 on the top. And then the bottom would be 9 plus 25. So I can clean up the bottom just a little bit more. So I'm going to bring the top over, because these two I can't combine, so I have to leave it the way it is. But 9 and 25 for the bottom do combine to give you 34, right? And once I notice that the bottom here doesn't have imaginary numbers, once the denominator has no more i's, you can say this is your answer. You are done. Okay. So this is your answer because there are no imaginary numbers. But here's the caveat. This is actually not the most simplified answer, but in Algebra 2, I will accept this answer. Here's the most simplified answer and the more nicer way to write it, especially if you go on to pre-calculus. So let me resize this to make some room here. Okay, so basically, if you have a 34 real number in the bottom, you want to divide each term by that number. So when you have more than 2 terms or more than 1 term on the top, you have to divide each term by the number in the bottom. So I'm going to go ahead and set that up. So that would be negative 6 divided by 34, and I'll put the I next to it, minus 10 divided by 34. So basically I took each term, made it, and divided it by 34, and I'm now going to simplify. What goes into 6 and 34 if I were to reduce? Well, 2 can divide into 6 3 times, and 2 can divide into 34 7 times. So in that case, this first term is now really negative 3 over 17i. And then this one here, 2 can go into, if I were to reduce, 2 could work. 2 can go into 10 5 times. 2 can go in 34, we just found out is 17 times. And so that's negative 5 over 17. And then it looks like I can't reduce anymore, so this really is my final answer. So this would be considered the most simplified answer. Okay, but you can definitely leave your answer like at here. So let me just explain what we did. So let me put some notes here. So to start this problem, you can't have imaginary numbers in the denominator. So because we had an imaginary number in the denominator, okay, we had to get rid of it. So to get rid of I, or imaginary numbers, you multiply by the denominator's conjugate. So you're going to multiply by the denominator's conjugate to the top and the bottom. And so that way your i's will cancel out, bringing you to a real number. And so then that way you can simplify it further. But yeah, that's what you have to do. You have to go find the conjugate. So really, division is going to feel more like a multiplication problem with simplification. So let's try another one. Don't add the denominator. All right, so here I have 2 plus I and 1 minus I here. And so again, I have an imaginary number in the bottom. So what I'm going to do to start is multiply the bottom by its conjugate to get rid of it in the bottom. So the conjugate of 1 minus I is 1 plus I. So I have to multiply the top by that 2. So that way, anything you multiply to the bottom, you must multiply the top, because anything over itself is just 1. So if I multiply this straight across, I have to FOIL the top basically and FOIL the bottom. I like to wrap parentheses around these terms, around these two terms, so that way it makes it easier for me to recognize to FOIL it. Just as a quick tip. All right, we're going to start with the top. So 1 times 2 gives me 2. 2 times I gives me positive 2i. I times 1 gives me 1i, and then I times I gives me I squared. All right, I'm done with the top. Now for the bottom here, 1 times 1 gives me 1. 1 times I gives me 1i. Negative I times 1 gives me negative 1i. Negative I times I gives me negative I squared. Now, I know that the bottom middle term are going to cancel because, you know, you multiply by the conjugate. So I'm going to cancel that out. Looks like I have an I square, so I'll change the signs there. And I have another I square on the top, so I'm going to change the sign there as well. So it looks like I have 2, and then these two are like terms. So 2i plus 1i gives me 3i. And then that I squared gets changed to a negative 1. And so I have the bottom as 1, the middle terms cancel, minus negative 1 because the I squared changes to a negative 1. And so from here, I'm just going to combine like terms, like 2 added with negative 1 gives me 1 plus 3i over, well, the bottom here, these are going to be turned into positive, so that's going to be 2 in the bottom. And so notice how the bottom here does not have I, so we are done. So this here is simplified because I can't add the top. I can't, there's no more i's in the denominator, so in this case, this is my answer. Now, here's the thing. If you want to simplify this more, you could, but I don't think you can really simplify this down as much as last time. So if you take 1 and divide it by 2, that's just 1 over 2, plus 3 divided by 2 is 3 over 2i. If you look at it this way, well, 1 and 2 don't simplify anymore, neither do 3 and 2. So you can write your answer like this, 2, or you could just honestly stop here. This is actually already simplified. So I'm just going to, you know, use this answer. I could use this one too. They're both the same meaning. All right, so let's try some problems we're solving for x. So these problems here are going to show up on packet 5, page 2, on problem like, I think it's like 7 and 8 that are like this. And then there are the 2 problems in the bottom of page 2. I'm going to show you some 2 examples using some ones that I've created. All right, so here we're now solving using square roots, kind of like what we did on Monday, okay? But these might involve some imaginary numbers. So we're solving, meaning we have to get x by itself. So if I have a problem like this, and here's my x squared, generally you want to start by trying to move everything to the other side, okay? So we're going to remove stuff one at a time. So if I want to get this x squared by itself, the further thing away is the 48, so I'm going to subtract over the 48 to both sides. So that cancels, bringing down the 3x squared equals negative 48. If I divide by 3, x squared drops down, negative 48 divided by 3 is negative 16. To get rid of a square, I have to take the square root. So the root and the 2 cancel, bringing down just the x, and the square root of 16, well, the square root of 16 itself is 4, but then it's a negative under this root, so I know it has to be an I, but because you took a square root, right, x is not just positive 4, it's positive and negative 4. So then finally, this here is your answer. So remember, when you're solving for x, you're going to have 2x value because this is x squared. So make sure you put the plus and minus sign. And if you see a negative, that means your answer should have an I if the negative was under a root. All right, let's try one more here. So there again is my x squared. I'm going to move the 10 over, and that makes negative 10. Cancel, and then I have 2x squared equals negative 10. I'm going to divide by 2 to get rid of this 2. And so then I have x squared equals negative 5. To get rid of the square, I take the square root. So the 2 and the root cancel, bringing down the x. The square root of 5 is not a nice square. So what I have to do is just keep it under the root, the 5 under the root. But because it's a negative, it's going to still need an I. And because you took a square root, it's still going to need a plus and minus sign in front. And so there we have it. We have our solution. So x is equal to plus and minus the square root of 5i. All right, that's it for today's journal. You should be able to do page 2 on packet 5 now with all of the notes. So make sure you look at the notes or watch the video if you need some extra help.